welcome to this explanatory video for the mathematical reasoning component of the Selective High School Placement Test. Today in this video, we'll be looking at the test paper and the changes to the structure of the test in comparison to the traditional mathematics paper. So the overall test structure. The mathematical reasoning component of the new selective placement test replaces the mathematics paper. The test consists of 35 multiple choice questions rather than the original 40. Each question has 5 possible answers, so either A, B, C, D, or E, of which there is one correct answer. Students will have 40 minutes to complete this paper. In regards to the test paper itself, the mathematical reasoning paper remains similar in format and style to the former mathematics paper. However, there is a far greater use of images, diagrams, graphs, and tables, and fewer questions involving calculations. Many questions were in the structure of which of these statements is correct, where students have to decide from a list of statements which are true and which are false from the given information. This means students will need to have good reasoning skills and understanding of real-world mathematical concepts. Compared to the original selective test, there are fewer questions related to ratios, speed, distance and time, and algebra. There are more questions involving fractions, probability, mass, volume, and geometry. Where algebra is involved, the guess and check method appears to be a more efficient approach. Because of the greater emphasis on mathematical reasoning instead of calculations, students are encouraged to think outside of the box and use their own logic and reasoning skills to come up with the answers. On the slide here, we have the sample test paper, which can be found on the New South Wales Government Education website, and the link is shown in the bottom here. So if you go to that link, you'll be able to find the sample test papers of all the various subjects, as well as the sample answer sheet, which can be used for practice. So for question type category information, so mathematical reasoning questions can be categorized into 3 main types, either finding procedures, identifying similarity, and relevant selection. Finding procedure questions make up a large majority of the mathematical reasoning paper. In these questions, students are given a verbal or visual stimulus. Using their skills in reasoning and understanding of mathematical concepts and operations, they will need to formulate a procedure or method to find a solution to the question. The method will not necessarily be immediately obvious to students, and thus they will need to think logically to find it. The second type, identifying similarity questions, mainly involve interpreting various types and sets of data, whether they are graphs, diagrams, or tables. Students will have to identify similarities and relationships between the data and use the information to draw conclusions. And the third category type, relevant selection questions, are about reading and interpreting a verbal or visual stimulus and determine what information in that is relevant or useful to solving the question being asked. These questions often involve number operations, graphs, and tables. Not all of the information will necessarily be used in determining the correct answer. Students will have to use their mathematical knowledge and deductive reasoning to decide what is relevant or not. In terms of the question categories, as seen in the sample paper, you can see here that there is a majority of finding procedure questions, as well as some relevant selection and identifying similarities. We can also see that there is a focus more on number concepts, simple number operations, and space and spatial reasoning. One thing to note is that the questions that appear in the sample tests are not all too different from what students have seen in the STTC. And we can see this when we go through the sample questions. So starting off with the first sample question, you can see the category is in finding procedures. We have number concepts, and the skills used is that making deductions using number knowledge and giving information to find the solution. So for the first question, we have Sandy's watch reads 18:50. What is the time 1/4 of an hour later in 12-hour format? So this type of question is very common also among STTC maths. So students have definitely come across this type of question where they are required to calculate using 24-hour time. So the way one would approach this question is that we can first convert 1850 into 12-hour format. So 1850, when we convert it, would be 6:50 p.m. And then we can read 1/4 of an hour later. So 1/4 of an hour is 15 minutes. And we are asked, what is the time 1/4 of an hour later? So we add this 15 minutes to the 6:50 p.m. which we would end up with 7:05 p.m. And we can see this is already in 12-hour format since we had converted it before. And so we can conclude that E is the answer. So this is one simple approach that students can take to find the answer for these type of questions. Looking at the second one, so we have finding procedures, but this time we have simple number operations, and the skills used is working with mathematical operators, problem solving and calculation skills. So looking at the second sample question, Jack divides a white wall into equal sections. He paints some sections purple as shown. Jack then paints 2/5 of the whole wall yellow. He then paints the rest of the wall green. So how many sections does he paint green? So we can use a visual method to approach the question. So students have also come across questions like these where they're required to use the given information and slowly work it out to draw a conclusion to find the answer. So the first thing that students should note is that there are 10 sections in total. And so if Jack paints 2/5 of the wall yellow, 2/5 of 10 is 4. So it means Jack would paint 4 sections yellow. And then we are told that he paints the rest of them green. So it means that there would be one section that would be painted green. And that is also what is asked for the question. And so we can conclude that A1 would be the answer. Looking at the third question, finding procedures, number concepts, and the skills making deductions using number knowledge and given information. The question asks, Nicola multiplies the smallest 4-digit whole number by the largest 2-digit whole number. What is the answer? Again, like the two questions we have seen before, students have come across these wordy type of questions where they are critically required to think about how to solve and approach this question. So looking at this question by each step, students can first identify the smallest 4-digit number as 1000, and then secondly, the largest 2-digit whole number as 99. We are also told that Nicola multiplies both of these numbers. So when we multiply both of these numbers, we get 99,000. And thus, we have A as the answer. So these type of wordy questions where you convert the given information to create mathematical operations has also been seen in Pre-Uni's STTC maths, and so students have come across these types of questions before. For the fourth sample question, we have relevant selection with the description of simple number operations and skills to identify and work with arithmetic operations. So looking at the fourth question, Rana needs 650 grams of cooking sauce. She places a glass jar of cooking sauce on a scale. The glass jar weighs 330 grams when empty. How much more cooking sauce does Rana need? So this question is a very straightforward mathematical question that students have seen before. Diagrams like this have been used quite frequently, even in current STTC from Pre-Uni. So this type of question is not completely new to students. The first thing we can do is identify the weight that is shown in the diagram. So we can see with the arrow pointing that there is 750 grams being weighed. We are also told that the glass jar, when empty, is 330 grams. So what we can do is subtract 330 grams from 750 to find how much sauce Rana currently has. When we figure this out, we have 420 grams. So this is how much Rana has now, but the next step is to identify how much she needs more. In the very first sentence, we are told she needs 650 grams. So to figure how much she needs left, we would need to do 650 grams minus 420, because 420 is the current amount of sauce she has. And when we figure this out, we get 230 grams. So as a conclusion, Rana needs 230 grams more of cooking sauce. And thus, we can say D is the answer. So this question is quite a straightforward question in terms of difficulty, and students should be confident with this type of question as they have seen this type of diagram before. For the fifth sample question, we have identifying similarity with number concepts and skills that utilize context and logical reasoning to determine unknowns and number relationships. So looking at the fifth question, calculator numbers are written in the style of digits on a calculator as shown. The calculator number 11 is the smallest two-digit number with 2 lines of symmetry, and you can see that below. So which of the numbers below is the largest two-digit calculator number that has just 1 line of symmetry? So questions involving symmetry or reflections across the x-axis or y-axis are types that students have come across as well throughout the mathematics paper. This question type, where a specific number of lines of symmetry are asked, are quite common across even the current STTC maths papers. So the way students should approach or can approach this question is to just go through each of the options and see whether there are any lines of symmetry, and if so, how many. And then we can single them out to find how many of them or which one of the options has just 1 line of symmetry. When we look at A, 52, we can see that there is no way that there is any symmetry either horizontally or vertically. So we can rule out as A is not the answer. For the second one, 83, we are able to see that there is a line of symmetry horizontally. So if we reflect it this way, we can see that there is a symmetry there. However, there is no vertical symmetry. So we can conclude that there is one line of symmetry in option B. To check, for option C in 88, there is symmetry in the horizontal axis as well as the vertical, because they are both the same number. So option C is incorrect, as there are 2 lines of symmetry, whereas we are looking for 1. In 96, for option D, there is no line of symmetry in these numbers. In option E, 99, there is also no line of symmetry, both either in the horizontal or vertical axis. And so therefore, from our checking through all the options, we can conclude only 83, or option B, has exactly one line of symmetry. So this is one way students can carefully check if numbers have lines of symmetry, is just for them to actually write it down and figure it out visually. Looking at sample question 6, we have category of finding procedures, description of number concepts, and skills to make deductions using number knowledge and given information. So looking at the question, Kim and Jamie each think of a different whole number that is greater than 0 and less than 50. Kim's number is a multiple of 5. Jamie's number is an even number, which is a multiple of 7. What is the difference between the largest possible value of Kim's number and the smallest possible value of Jamie's number? This type of question is also quite common, where there are two separate scenarios. So in this case, Kim's number and Jamie's number, and then using that piece of information to have those two pieces come together for a certain condition, and then where students should find the answer. So the way to approach this question is that we can firstly look and try to think of what Kim's number could be. So we know Kim's number is a multiple of 5. So there are many multiples of 5 that are less than 50. But to narrow our possibilities down, we know that we want to find the largest possible value of Kim's number. So the largest possible value that is less than 50 and is also a multiple of 5 is 45. So students should be aware that less than 50 does not mean include 50. So hence why we see that 45 would be the biggest. So this might be a common fall for students if they don't read the question carefully. So since we have figured out Kim's number, let's figure out Jamie's number. So we know that it is an even number, which is a multiple of 7. And our other condition is that it should be the smallest possible value. So when we list out the multiples of 7, we have 7, 14, 21, and 28. So these are the first 4. We see that 14 is both even and a multiple of 7, but also the smallest multiple. So we can conclude that would be Jamie's number. Now with these two scenarios, the numbers 45 and 17, we are asked to find the difference. So the way to do this is to subtract 14 from 45, and we should get 31, which makes A our answer. So for these type of questions, students should carefully read the pieces of information and to break them up so it doesn't confuse them. If students are able to read these sentences one at a time, they will be able to create a more efficient and concise approach in how to answer the questions. For question 7, we have the category Identifying Similarity, the description of space and spatial reasoning, and skills of accurately interpret visual stimulus and its properties. So looking at the question, rectangles P and Q both have the same area. So what is the length of rectangle Q? Again, these type of questions where some pieces of information are given to solve an unknown length or dimension has appeared quite frequently in the STTC maths papers. So students should be familiar with these type of questions and seeing these diagrams in the test papers. So what we want to do first to try and approach this question is to use the given information to find the calculations that will help us to find unknown lengths or dimensions. So in this case, we want to find the length here. We can firstly look at rectangle P. We see that both the length and width dimensions are given to us, and thus we can firstly find the area of that rectangle. So area of rectangle P is the length times the width, so 10 by 6, which is 60 centimeters squared. So that's the first step. Now looking back at the question, we are also told that both P and Q have the same area. So what students can do next is to formulate an equation where we have 60 is equal to the area, so the length and the width of rectangle Q. Now what we can do is easily solve this. So we just have to divide 60 by 4 because we want to bring length to its own side. So we can write length is equal to 60 divided by 4, which is equal to 15. So therefore, through the visual stimulus in creating our equations, we can conclude that the length of rectangle Q is 15 centimeters. So C is the answer. For the 8th sample question, so for the category, we have relevant selection, description, simple number operations, skills, identify and work with arithmetic operations. For question 8, so Soo-young has a glass containing 250 milliliters of cordial and a bottle containing 1 liter of water. So we can see the diagram below. Soo-young drinks 10 milliliters of the cordial. She finds the drink too strong, so she pours water from the bottle into the glass until the water reaches the 500 milliliter mark. How much water is left in the bottle? So for these type of questions, these are also similar to the diagram questions that we have seen below with the pasta sauce and the weight. So again, we have several pieces of information that we can use to try and solve the answer. So to solve this question, students can try and approach first by looking at this sentence. We can firstly calculate the amount of cordial left in the glass after Soo-young has drunken 10 milliliters of the cordial. So we can see from the diagram that there is 250 milliliters of the cordial and Soo-young has drunken 10 milliliters. So thus there would be 200 milliliters left. And then we are told that she finds the drink too strong, so she pours water from the bottle into the glass until the water reaches the 500 milliliter mark. Now we want to find how much water she adds into the glass. So if she fills it up to the 500 milliliter mark, we can create this equation to solve how much water she added. So 500 minus 240 is 260. So this is what she added, how much water she added into the glass. Now the question asks how much water is left in the bottle. So to solve this, we know that the bottle has originally 1 liter, or if we convert it to milliliters, 1000 milliliters. And we know that Soo-young has poured 260 milliliters into the glass. So we can create this equation to figure out how much water is left. And when we solve this, we get 740 milliliters. And so we can conclude that C is the answer. There is 740 milliliters left in the bottle. So this question is quite similar to the ones we have done before, as well as the type of questions students have come across during STTC. So this shouldn't be all completely new for the students. Looking at question 9, for the category we have finding procedures, and the description mixed number operations, skills working with mathematical operators, problem solving and calculation skills. So for question 9, a square always represents the same number. The triangle represents a different number. So if 9 times square is 108, and a triangle plus a square is 36, what is the value of the triangle? So these type of questions are very common across both maths and the GA papers. They involve simultaneous equations and finding unknowns. So what students can do is to formulate simultaneous equations between these two here to get the answer. So a way we can solve is to just firstly rewrite 9 times the square is 108. Just to make it a bit easier, 9 squared is 108. And then we can easily solve by dividing by 9 on both sides. So we can get the square to be 12. So this is the value of the square. And so what students can do now is that once they have found that value, we can sub it into the second equation that we have. So we know that a triangle plus a square is 36. And we know that a square is equal to 12, so we can sub it in as a triangle plus 12 is 36. And then subtract 12 from both sides to get 24. We can see that option C would be the answer. So questions like these are very common, and students have seen these type of questions before. So they are not all too different or not too difficult for them. For sample question 10, we have category finding procedures, the description, space and spatial reasoning, and skills recognizing object and spatial position. So looking at the diagram in question 10 and the question, Tani is making a pattern out of white and black tiles. She hasn't finished yet. She wants the finished pattern to have one vertical line of symmetry. What is the smallest number of tiles she needs to add onto the right of the pattern? For this question, this is quite common in the GA as well as the maths, where students need to figure out the spatial position as well as colors and symmetry as well. So one way students can approach this question is to just visually think and analyze what tiles are missing to create the line of symmetry. So we know we want to add some tiles to this end of the diagram because we are told that she needs to add to the right of the pattern. So we can visually see that the line of symmetry would be around here. But to figure out which tile, we can try and see what symmetry patterns can we currently see. Well, when we look carefully, we can create a line of symmetry in the middle here. And thus, so we have these tiles which are symmetrical. This one, this black tile, but we see that these two tiles are missing on this end. So we would need to have a black tile here, and then a white tile to create a vertical line of symmetry. And so if we add two tiles, we can get this vertical line of symmetry across this axis. So we can conclude that Tani would need at least 2 tiles to create a vertical line of symmetry. So for this question, students just need to critically think and visualize where the line of symmetry could be placed in order to create the smallest number of tiles. For question 11, we have the category finding procedures, the description mixed number operations, and skills working with mathematical operators, problem solving, and calculation skills. So looking at question 11, Jessica has blue, green, red, and yellow buttons in a bag. There are twice as many red buttons as blue buttons. If she takes one button out of the bag without looking, the probability that it is blue is 0.2, and the probability that it is green is 0.3. So what is the probability that Jessica takes out a yellow button? So probability questions like these, with many layers of information, are also quite common across maths in the current STTC papers. So students are quite familiar with having several pieces of information, as well as situations with colored buttons and figuring out the probabilities of picking out a certain color. So one step, or the first step that students can do, is to just write out the different colors that are mentioned. So blue is represented by B, G is green, R is red, and Y is yellow. In the second sentence, we are told that there are twice as many red buttons as blue buttons. So with this information, we can create that one red button would equal the probability or the number of two blue buttons. Then we are also told the probability of picking out a blue button is 0.2, and the probability of picking out a green button is 0.3. Now, with this in particular, if a blue probability is 0.2, and we know that there are twice as many reds as blues, we can conclude that the probability of picking out a red button would be 2 times the probability of picking out a blue, which is 0.4. So now we have the probabilities of these three colors, and the question asks, what is the probability that Jessica takes out a yellow button? So to do this, we would need to firstly add up all the probabilities that we know of the other three colors. So we have 0.2 plus 0.3 plus 0.4, which is equal to 0.9. And then what we do is we subtract it from 1 to get the probability of yellow, which is 0.1. Because we know that probabilities should always equal to 1, and we know that these are the sum of the other three colors, which makes 0.1 the probability that a yellow button would be picked out. And so we can circle that A 0.1 is the answer. So students can work out these type of questions in a logical mathematical format using several pieces of information together to help create and find the answer. Looking at question 12, we have relevant selection and the description for graph, and skills recognize, manipulate, and interpret data values. So now looking at the 12th question, the graph shows the average monthly rainfall for Cairns for 1 year. So we are given a graph, and here are 3 statements about the graph. So 1, June had more than twice as much rainfall as August. 2, December had 9 centimeters more rainfall than November. 3. The rainfall in February, March, and April combined was more than 1 meter. So which of these statements are correct? So this type of question is also very common across the maths STTC papers, where students are given a certain graph, not necessarily a column graph like this or histogram, but also bar graphs, as well as line and plot graphs. And then they are also given a section for pieces of information where students will analyze and sift through to find the answer. So one approach that students can take to answer these type of questions is to go through each statement and see if they are true or not. So let's do just that and look at the first statement. So June had more than twice as much rainfall as August. So firstly, when we look at the graph, we know that each line is going up by increments of 10 millimeters. So firstly, if we look at the rainfall for June here, we know that when we line it up, we know that June had a rainfall of 70 millimeters. So we'll just write that here. So June is 70. And for August, when we line it up, we see that it had 40 millimeters. And we know that 2 times 40 is 80. But June had 70, which is less than twice. So therefore, we can conclude that statement 1 is incorrect. Looking at the second statement, December had 9 centimeters more rainfall than November. So firstly, look at December. When we line up the graph here, we see that the rainfall is 190 millimeters. So for statement 2, December is 190. Now looking at November, since we're comparing those 2 months, when we line it up, we can see that November had 100 millimeters. So we can write 100. And to find how much more rainfall December had in comparison to November, we can subtract. So we have 90 millimeters more. And if we convert it to centimeters, we get 9 centimeters, because there are 10 millimeters in 1 centimeter. So we can conclude that 2 is correct. And looking at the last one, the rainfall in February, March, and April combined was more than 1 meter. So firstly, looking at February, if we line it up here, we know, or you can see that February had 430 millimeters. When we look at March, we see that it had 440. And then lastly, for April, when we line it up, it's 230. And so we add all of them together, and we should get 1,100, which is equal to 1.1 meters, which is greater than 1 meter. So statement 3 is also correct. And so when we go down to the options, which of these statements are correct? You know that D is the answer. Statements 2 and 3 only. So for these type of questions, students should pay careful attention especially when reading the graphs, because some of the lines can be quite tricky and they might misread. They also should be careful when doing their addition or mathematical operations to minimize errors. Looking at question 13, so we have finding procedures and the description, simple number operations, skills, working with mathematical operators, problem solving, and calculation skills. So looking at question 13, Alan had $10. He gave some money to Kiana. Alan then gave half of what he had left to Jason. Jason gave half of what was given to Lenny. Lenny received $1.60. How much did Alan give to Kiana? So these questions are quite common across both GA and maths papers in the current STTC. They involve an unknown numerical number or value and require to work backwards or to create equations to find the unknown. So one way students can approach this question is to let X equals money given to Kiana. So this approach among students to let a certain unknown number be a pronumeral is a common method. And then we can work through each of the sentences to create our equation to solve the answer. So Alan had $10 and he gave some to Kiana. So if we create this equation, this is how much he has left after giving to Kiana. Then we are told that he gave half of what he had left to Jason. So this is what he had left, and he gave half of it to Jason. So let's have J for Jason there. So that's Jason's value of what he got. And then from there, he gave half to Lenny. So Jason gave half of what he was given to Lenny. So divide by 2, and that is Lenny's value. So L for Lenny, so we can simplify that. And this is what Lenny was given. And then we are lastly told that Lenny was given 160. So we can have this equation, which we can now solve easily. So going up, so we have 10 minus x is equal to 6.4 because 4 times 160. And then we can have x is equal to 10 minus 6.4, which is equal to 360. And since we let x be the money given to Kiana, Kiana received $3.60, which makes B the answer. Now on to question 14, where we have categories identifying similarity, description, space and spatial reasoning, and skills accurately interpret visual stimulus and its properties. So looking at question 14, Noah is drawing an accurate copy of this shape. So seen here, the shape has one line of symmetry. He starts drawing the shape as follows. On the protractor here, what is the angle? What is the size of angle S? So for this question is not as commonly seen in the STTC, but can come up and is quite straightforward for students. So what students are required to do is to translate this image, knowingly that they have one line of symmetry, onto the protractor here to find the angle. So what students can do is to draw the lines like on this side as well, to find the angle here. So since we know that there is one line of symmetry, we can just follow the lines markings here and do it on the same side here. So students can follow the lines here as well as on the 50. And thus having angle S here. So to find the size, we can just count the increments of 10. So we have 10, 20, 30, 40, 50, 60, 70, 80. And thus the angle size of S is 80. So this question, students can visually draw it to help them solve the question. For question 15, we have the category finding procedures, the description, simple number operations, its skills, working with mathematical operators, problem solving, and calculation skills. So looking at question 15, when 117 chocolates are shared between 14 people, each person gets 8 chocolates and there are 5 chocolates left over. Which number sentence shows this information? This type of question is quite common where students are required to use wordy information to create an equation. So this type of question is not completely new for students. So to approach this question, we can firstly just look at the first pieces of information. So when 17 chocolates are shared between 14 people, each person gets 8 chocolates and there are 5 chocolates left over. So we can firstly write that the chocolates are shared between 14 people, and if each person got 8, there would be 5 left over. So 5 left over, and that would all equate to 117 chocolates. So working through bits and pieces of information, we can gather that the answer is E. So students should read carefully to be able to understand the information and to be able to convert it to a mathematical equation. In question 16, we have the category finding procedures, the description, 2D shapes, skills, identify features, patterns, and characteristics of 2D shapes. So looking at question 16, so we have a diagram, and a large rectangle has sides 8 centimeters and 10 centimeters. 2 small rectangles are removed from this large rectangle. This leaves the shaded shape. What is the perimeter of the shaded shape? So questions with diagrams, perimeters, and missing shapes are very common across the maths papers, and students have definitely come across these type of questions, so they are not all too different to the old structure of the mathematics STTC. So what students can do first is to identify the missing dimensions. So for example, here, and the missing sides here. Firstly, for this side, we know that the missing piece here is 5 centimeters and the overall length is 8. So we can do 8 minus 5, which is 3. And then we know as well that this side is 3, which means this side should also be 3. Now for this sides here and here, if we visualize it going upwards here as represented by the dotted lines here, it would be 10 centimeters. So we can just still calculate as this side as 10. And thus we have all the information we need to help us find the perimeter. So we can write our simple addition as 10 plus 10 for the 2 side lengths, plus 5 plus 3 for the sides here, plus 8 for the overall side length, and then plus 3 and another 3 for the inner lengths. And when we calculate that, you should get 42 centimeters, which makes E the answer. So this question is not too difficult on the scale of other questions, but students should be careful of the measurements and other tricks that they can identify to find the perimeter more easily. For question 17, we have the category identifying similarity, the description of making conclusions, and skills to accurately interpret and infer a conclusion from given stimulus, clues, and logic. So when we go in, so Andy, Bella, and Carlo shared a chocolate bar. Andy ate 1/5 of the bar, Bella ate 2/5 of the bar, and Carlo ate the rest. Which of the following statements are correct? So which of the following statements are correct? 1, Carlo ate less than half of the chocolate bar. 2, Andy ate more than 1/4 of the chocolate bar. And 3, Andy and Bella ate less than 3/4 of the chocolate bar altogether. So again, like the graph question that we have seen before, we are given a diagram or stimulus and statements that we have to find and analyze if they are true or not. So again, a method students can take is just to go through each of the statements and see which ones are correct or incorrect. So looking at the first one, Carlo ate less than half of the chocolate bar. So from the information, we know that Carlo ate the rest. So firstly, let's figure out how much Andy and Bella ate. So from the diagram, it is handy that it is already split into 5 parts. So we know that Andy ate 1/5, so Andy's piece. Bella ate 2/5, which means Carlo ate 2/5 as well as Bella. So looking at the first statement, Carlo ate less than half of the chocolate bar. Well, 2/5 is less than 1/2, so that is correct. Number 2, Andy ate more than 1/4 of the chocolate bar. Well, 1/5 is smaller than 1/4, which means that statement is wrong. And third, Andy and Bella ate less than 3/4 of the chocolate bar altogether. So Andy ate 1/5, Bella ate 2/5, which makes 3/5. So 3/5 is equal to 0.6, and 3/4 is equal to 0.75. And we know that 0.6 is less than 0.75, which means that Andy and Bella did eat less than 3/4. So statement 3 is correct. So if statements 1 and 3 are the only ones correct, it means E is the answer. So again, students are encouraged to work through each statement one by one to help solve the question and to make it easier to come to the conclusions. For question 18, we have the category finding procedures, the description simple number operations, and the skills working with mathematical operators, problem solving, and calculation skills. So in a magic square, each row, each column, and each diagonal add up to the same total. In the magic square below, some of the numbers are missing. So we are given the square here. So what is the missing number at the diamond? So magic square questions and additions where rows and columns are equal to one another are quite common, particularly in the GA. So students have come across these types of questions and are not all too unfamiliar with them. So what we can do first is that students can try and find what the total is for each of the row, columns, and diagonals. Since we have 3 values here, what we can do first is to just add them up to find the totals that each row, column, and diagonal should equate to. So when we do 20 plus 15 plus 16, we should get 51. And so this is the total we are always looking for. Secondly, we can find this missing number because we have 2 numbers already here. So we can have 18 plus, let's say the blank is an x, plus 16 is 51. And then x, bring everything to one side. We get x is 17. So this number here is 17. And then lastly, we can solve the diamond here because we know 20 and 17 here. So 20 plus 17 plus the diamond is 51 because we know that the diagonals also add up to the rows and columns. They are all of equal value. So the diamond is 51 minus 20 minus 17, which is equal to 14. And so we have B as the answer. So for these type of questions, students should look for what pieces of information is given and what summations or subtractions they can do to help fill in the missing numbers, and then lastly come to the unknown that they have to find. For question 19, we have the category identifying similarity, description, making conclusions, and skills accurately interpret and infer a conclusion from given stimulus, clues, and logic. So looking at question 19, Chen has a spinner that is split into 4 equal sections. So he spins and it lands on a 4. Now Emily is going to spin the spinner once. Which of these statements are correct? So either X, the probability of Emily of getting a 4 is 1/4. Y, the probability of Emily's number is less than Chen's is 1/2. Z, the probability that Emily and Chen's scores add up to make more than 5 is 3/4. So again, similar to 2 other questions we've done before, we will be going through each of the statements and see which one is correct. So for X, the probability of Emily getting a 4 is 1/4. Well, we know that the diagram and the spinner is separated into 4 and there are only 4 options. So it means that there is a 1/4 chance of getting each number, which means X is correct. Y, the probability that Emily's number is less than Chen's is 1/2. So Chen got a 4. And we know that the numbers less than 4 are 2 and 3, so which makes up 2 of the 4 options, which is 1/2. So that is also correct. And then the probability of Emily and Chen's scores add up to make more than 5 is 3/4. Well, we know that if Chen got a 4, it means any number that Emily lands on would be greater than 5. So for example, if we take the smallest on the spinner, a 4 plus a 2 is 6, so that is already greater than 5, which means that any number that Emily gets will definitely and 100% be greater than 5. So the probability would be 1 rather than 3 on 4, which makes X wrong. So from this, we know that only statements X and Y are correct. So students should be familiar with these type of questions. We've also done a few previously. So we know that there are different types of diagrams or graphs or sets of data that can come up. and thus students should work chronologically to be able to sift through each of the statements and analyze them to come to the answer. For sample question 20, for the category we have identifying similarity, the description, space and spatial reasoning, skills, accurately interpret visual stimulus and its properties. The question, there is something wrong with these scales. As shown, the pointer does not start at 0 kilograms when there is nothing on the scales. We can see through the diagram here. Apart from this, the scale works normally. The pointer goes up by 1 kilo for every kilogram added to the scales. So 2 identical blocks are placed on the scales, which are seen here. The pointer makes less than a full turn. What is the mass in kilograms of one of those blocks? So firstly, these type of questions are quite common in maths, where we have an original scale with maybe an error in the numbers, and then some item placed on it, and we have to try and find out the value of one of those items. So this question is a familiar type that students should be accustomed to. So we can firstly try and find out the mass of one of these blocks according to this scale. So the scale is going up by 2 kilo increments. So what we can do is firstly read the scale. So we can see that it is saying 44. And we know that there are 2 blocks. So divide it by 2, get 22. And now secondly, from this scale, the fault is that it is 8 kilos heavier when there's nothing on it. So this 22 should be 4 kilos lighter because we have 8 divided by 2 blocks, which is 4. And then 22 minus 4 is 18. So each block is actually 18 kilos. Now this is one method that students can do. Another way that will get you the same answer is to actually do it as 44 and firstly take away the 8 kilo fault to get 36, which is the true weight of the 2 blocks, and then do 36 divided by 2 to get 18. So you can see that these 2 methods still get you the same answer, but this is just to say that there is more than one answer or one way to get to the solution. In question 21, so we have the category finding procedures, the description, number concepts, skills, making deductions using number knowledge and given information. So for question 21, Alinta and Tao both round the number 4,850,000. Alinta rounds the number to the nearest million. Tao rounds the number to the nearest 100,000. What is the difference between the answers? So again, this number type question is quite common, where you have 2 separate pieces of information, and then you can use them together, combine it, to find what the question is asking you to do. So we can firstly look at Alinta's situation. So we have 4,850,000. Now for Alinta, we know she rounds to the nearest million. So the nearest million would be 5 million. And then for Tao, she rounds to the nearest 100,000. So looking at this place here, and then so she rounds to 4,900,000. And then we are asked to find what is the difference between their answers. So what do? We just subtract 4,900,000 from 5 million, and we get 100,000. So we have C as the answer. So this question is quite similar to one that we have done before in this sample test. So students should be aware of the different pieces of information, and then once they have found each separate answer, combine it or use it together to find the final answer. So sample question 22, we have the category relevant selection, description graph, skills, recognize, manipulate, and interpret data values. So here is a graph showing the outdoor temperature during a period of 9 hours. Which of these statements are true? So 1, the temperature was 10 degrees Celsius at 4 different times. 2, the temperature change between 1 hour and 3 hours was greater than the temperature change between 4 hours and 6 hours. And 3, the lowest temperature was 5 degrees Celsius. So again, this is a very similar type question to what we have done before. So we will just go through each statement to try and find the answer. So students can start with the first statement. The temperature was 10 degrees at 4 different times. Well, we see 10 degrees here, 1, 2, 3, and 4 here. So indeed, statement 1 is correct. Number 2, the temperature change between 1 hour and 3 hours was greater than the temperature change between 4 hours and 6 hours. Well, if we look at the change in the first hour, so it was 10, and then in hour 3, it was 18. So statement 2, 18 minus 10 is 8. And then between 4 hours and 6 hours, so 4 is 20, and 6 is 13. So we have 20 minus 13, which is 7. So indeed, the temperature change earlier was greater than 4 hours and 6 hours. So that is also correct. And then the lowest temperature was 5 degrees. So we look along this line, and we see indeed that here 5 degrees was the lowest. So that is also correct. So when we go down, it means that all the statements are correct, and thus E is the answer. So again, students should just work through each of the statements and analyze the graph carefully to come to the answer. For question 23, finding procedures is a category. The description, simple number operations. Skills, working with mathematical operators, problem solving and calculation skills. Kwok bought 4 pizzas to share with Amina, Fred and Sally. Amina ate 4/5 of the pizza, Fred ate 1 1/5 pizzas, and Sally ate 3/5 of a pizza, and Kwok ate all of the pizza that was left. So how much more pizza did Kwok eat than Amina? So these fraction type questions where people are involved and pizzas or foods are involved are quite common in maths, and so students should be familiar with these type of questions. So we can simply work out these questions mathematically by firstly we can calculate. So there are 4 pizzas in total. So if we convert it into fraction form, we have 20 on 5, which is equal to, let's X be Kwok's shares plus all the pizzas that these people ate. So Amina's is 4/5. Fred is 6/5, so we just convert it to an improper fraction to make it easy to calculate. And then Sally is 3/5. And so we get X plus 13/5. So when we add up all of this, and then we have X is equal to 20/5, take away 13/5, which is 7/5. So this is how much Kwok ate. So we want to find out how much more did he eat than Amina. So how do we do this? Simply subtract. So we have Kwok's portion minus Amina's portion, which is equal to 3/5. And thus, we can conclude that B is the answer. Kwok ate 3/5 of a pizza more than Amina. So you can see here we have also let pronumerals into our equations, and this is quite common across this new curriculum as well as what was seen in STTC previously. So students should be comfortable with these type of questions. For sample question 24, we have the category identifying similarity, the description, quantitative data, and the skills recognizing data from graphs to determine plausible statements. So for the question below, 3 different boxes are weighed in pairs. Different pairs of boxes have combined weights of 28 kilos, 32 kilos, and 38 kilos as shown. When the 3 boxes are weighed together, what is their combined weight? So for this question, students should realize that there are 3 unknown values that they are trying to find. The best way to approach a question like this is to use simultaneous equations using the information given. By using the simultaneous equations together, after they have figured out each one, this will help students to come to the unknown values. So from the information here, we can start off by labeling each box as A, B, and C to make it easier for us to figure out. So for box A, we can label here. We can use it to represent the brownish reddish box. For the blue pattern one, we can label as box B. And for the black one, we can label as C. So now that we have given each box a letter, we can create our simultaneous equations. So looking at the first scale here, we can write out box A plus B is 28 kilos. So that's our first equation. Second one here, we have box A plus C, which is 32, and that's our second equation. And then we have our third scale, we have box B and C, which is 38. And that's our third equation. The next step, we can use these equations together to figure out our values of the boxes. So there are many ways you can approach this and which equations you can use, but for one approach, we can do equation 3 minus equation 2. So we can write it as B plus C is 38 minus A plus C, which is 32. And then so when we subtract 2 from 3, we end up with B minus A is equal to 6. And then we can rearrange that to have B is equal to 6 plus A. And then we can sub this new equation into equation 1 because we haven't used that one yet. So when we sub it in, we have A plus 6 plus A, which is 28. So note this is box B. And then when we simplify, we have 2A plus 6 is 28. And then we figure out 2a is equal to 22 as we take away 6 from 28. And then when we divide, we are left with a is equal to 11. So that's one value of the box found. And then now we can use this information to figure out boxes B and C. So from equation 2, we have A plus C is 32. We know A is equal to 11, so we can sub that in. So 11 plus C is 32. So therefore, box C's weight is 32 minus 11, which is 21. So box C is equal to 21 kilos. And then lastly, we can use A again to find the weight of box B. So from equation 1, we have A plus B is 28. Sub in 11 for A. So 11 plus B is 28. And so therefore, B is 17. So now that we have found the weights of each of the 3 boxes, we will add them all together because the point of the question is to find their combined weight. So to find the combined weight, we do A plus B plus C. So boxes A, B, and C, which is equal to 11 plus 21 plus 17. So when we add that up, we get 49. And this is our answer. So A, 49 kilos, is the correct answer. So you can see here how useful using simultaneous equations are in trying to find the values of unknowns, not just for this question, but for a various number of scenarios. In the STTC Maths and also GA, students have come across these type of questions where they are required to use simultaneous equations. So if students aren't familiar with this method, it is strongly encouraged that they do so because they will come very handy in lots of questions. Now going on to question 25. So we have finding procedures for the category, the description, 2D shapes, and the skills, identify features, patterns, and characteristics of 2D shapes. So the question asks, what is the sum of the number of faces, number of edges, and the number of vertices of a pyramid with a hexagonal base? So this question is also quite common across maths when you count the different components of a prism or pyramid. So one way we can solve this is to actually draw the shape. So a hexagonal base and then the sides of the pyramid. So now we can count one by one the faces, edges, and vertices. So the faces, if we count, there are 7 faces. So the base plus the 6 sides. If we count the edges, there are 12 edges. And vertices, which are the points. So here and here, for example, we have 7. Now we just add all of these together, like the question asked us to do, and we get 26. So the sum of faces, edges, and vertices for this pyramid with a hexagonal base is 26. So D is the answer. So students are strongly encouraged to actually draw the shape rather than try to think of it mentally in their own head, so that they are able to more easily calculate the faces, edges, and vertices. In sample question 26, we have the category finding procedures, Description, make number concepts, and skills, making deductions using number knowledge and given information. So in question 26, in our number system, the value represented by a digit depends on its position. For example, the number 273, the 7 represents 70. In the number 30,060, how many times larger is the value represented by the digit 3 than the value represented by the digit 6? So again, these wordy questions are quite common against Pre-Uni's STTC maths, and so students should be quite familiar with picking out the information. So an approach to do this is to just figure out the value of the digit 3 and then separately the digit of 6 and then just to divide it. So the value of the digit 3 is 30,000. And then we are dividing by the value of the digit 6, which in our number is 60. And so we get 500. Thus, it is 500 times larger. In sample question 27, we have the category finding procedures, the description quantities and skills, working with mathematical operators, problem solving, and calculation skills. So for 27, Kylie lives in Las Vegas and she visits her cousin Mike, who lives in Sydney. Kylie leaves Las Vegas on Friday at 1300 local time on a 6-hour flight to New York. She then spends 24 hours in New York and then catches a 20-hour flight to Sydney. The time in Las Vegas is 17 hours behind the time in Sydney. What time is it in Sydney when Kylie arrives? So for these type of questions, time zones are quite common, both in maths and GA, where students have to utilize the knowledge and calculations between two locations to figure out the solution. So this type of scenario question is very common and students have definitely come across it. So what we can do first, an approach, is just to calculate everything in Las Vegas time and then at the very end, account for the Sydney time. So we can find out what time it is in Sydney when Kylie arrives. So firstly, we know that she wants to come to Sydney, but before that, she leaves for Las Vegas at 1300 local time, so 1 p.m. on a 6-hour flight to New York. So 1300, so 1 p.m. plus 6 hours is 7 p.m. Shows she's in Las Vegas on the Friday. So keep in mind this is all Las Vegas time. So Las Vegas and Friday. And then we know that she stays there for 24 hours. So again, Las Vegas time, but it is now a Saturday. And then we know that she catches a 20-hour flight to Sydney. So we want to count from 7 p.m. on a Saturday plus 20 hours, which makes it 3 p.m. Las Vegas time on a Sunday when she arrives in Sydney. But now she's in Sydney, we want to account for the time that she has arrived in Sydney. We know that Las Vegas is 17 hours behind in Sydney. So what we have to do to the time here is to add 17 hours. If we add 17 hours, we get 8 a.m. Sydney time on a Monday, because it is the next day. So it is Monday, 8 a.m. in Sydney when Kylie arrives. So for these questions, students might struggle and find it confusing with the time zones, but they should work at it one step at a time so that they can easily calculate the time zones and also the days more easily. For question 28, we have the category finding procedures, the description 2D shapes, and skills identify features, patterns, and characteristics of 2D shapes. In question 28, here is a shape made of black and white parts. What is the total area that is black? So for this question, this is quite common and not completely new, where we have different bits and pieces where we have to subtract and add areas to find the total area that we want to find. So a way to approach this question is to firstly, we can calculate this small square here. And so what we can do first is write 2 by 2 in brackets, and then we're going to add this larger square here minus the white square, because we want to account for the missing area. So the second largest black whole square is 4 by 4, when we add all of these numbers, minus 3 by 3, which is seen here. And lastly, add this larger number, take away this white square here, again accounting for the missing space. So we have 2 plus 1 plus 1 plus 1 plus 1. So we have 6 by 6 minus this white square's dimension, which is 5 by 5. And so when we calculate this using our simple arithmetic method, we have 4 plus 16 minus 9 plus 36 minus 25, which is 4 plus 7 plus 11. And in total, we'll get 22 centimeters squared. So from our options, we have D as the answer. So students should just be aware with the dimensions and the calculations when approaching this type of question. When we look at sample question 29, we have the category relevant selection, description, simple number operations, and skills identify and work with arithmetic operations. So for question 29, Jan is making a mixed fruit drink for a party. She puts some orange juice into the jug as shown. She then adds 6 times as much apple juice. How many milliliters of fruit drink does Jan make? So again, with measurements and calculations, this question is not too unfamiliar for students. So for an approach for this question, we can firstly calculate how much juice is already in the cup or the jug. And it goes in increments of 25 milliliters each. And it goes up in 50 milliliter increments. So we can firstly write 150 milliliters is equal to orange juice. And then we know that Jan adds 6 times as much apple juice. So 6 by 150 milliliters is equal to the apple juice. So 6 by 150 is 900, is equal to the apple juice, so the AJ. And then to find the total amount of juice, we just add those two together to get 1050 milliliters, which is D. So again, this question is quite straightforward and requires students just to look at the diagram carefully and to also carefully understand what the question is asking. For question 30, category is finding procedures and the description is space and spatial reasoning, with the skills as well as recognizing object and spatial position. So the equilateral triangle above is rotated anti-clockwise into the position shown below. Through what angle is it rotated anti-clockwise? So anti-clockwise, we are circling this way. And so for this question, This type of question with triangles and arrows has been seen in particularly the GA questions. So students should be able to critically think and calculate the angle size. So if we firstly just calculate a triangle like this with the arrow facing down, we know that's turned 180 degrees. But then if we turn it again slightly, we can get this. And because it's an equilateral triangle, it will turn in 60 degrees increments. So we have 60 degrees. And then we just add these two together to get 240 degrees. So we know that the angle has rotated 240 degrees anti-clockwise. So it's through a simple process and doing it step by step that students should be able to complete the question correctly. For question 31, we have the category finding procedures, the description, space and spatial reasoning, and the skills recognizing object and spatial position. So for question 31, Vinayak's little brother tried to draw 3 different nets of a cube, but he got it wrong. He only drew 5 squares for each net, but a complete cube net has 6 squares. So here are his 3 drawings. Vinayak wants to help by adding 1 more square to each net to make a correct cube net. However, he is not sure if this is possible for all the drawings. So which of the 3 drawings can be made into complete cube nets by adding 1 square? So this question type is similar to the graph types where we have to pick out 3 statements, but instead it's kind of the reverse way around where we have to pick out 3 of the diagrams. So again, we can just try and add a square here and there for each of the cube nets to see which one is truly one that can form into a cube. When you look at the first one should realize that if this net without a 6th square was to be folded up, there would be overlapping bits. And so thus, the top for this and this square makes it impossible for a cube to be formed. So 1 is incorrect. For 2, if we roll it up, we can see that a side is missing. And we can actually add a square here so that when it is formed, a whole cube can be created. So 2 is correct. With 3, similar to the first problem, this square and this square would actually overlap if you try to create a net. So 3 is wrong, which leaves only drawing 2, a true cube, and that where a 6th square can be added for a cube to be formed. So for this question, students should try to visualize the cube net and try to form it themselves in their head and try to pick out where an extra square could fit in. Now on to question 32, where we have the category finding procedures, description, 2D shapes, and skills, identify features, patterns, and characteristics of 2D shapes. So Harry is making shapes out of identical rectangular cards with the letter H on. He makes shape X, then adds another card to make shape Y, as shown. The perimeter of shape X is 64 centimeters, and the perimeter of shape Y is 82 centimeters. What is the width of each of Harry's rectangles? So this type of problem-solving question is also quite similar to what appears in the maths questions towards the end, so it shouldn't be too unfamiliar for students. So one way to approach this question, we know that this shape appears in this shape here as well. So what we can do is firstly just to have 82 minus 64, which is 18. Now what we see here is that this perimeter is covered, or this side length is covered rather. And so we can visualize that this side length is also pushed down here, meaning the width would just be 18. So two width lengths is 18. So 18 divided by 2 would give us one width, which is 9 centimeters. So E is the answer. So students should try to think critically for these type of questions because there are some hidden lengths or unknowns that can make it tricky. For question 33, we have the category finding procedures, description, number concepts, and skills making deductions using number knowledge and given information. So Claudia makes a number pattern using these rules. Choose the first 3 numbers. After this, each number is the sum of the 3 numbers before it. Here is Claudia's pattern with 3 missing numbers labeled X, Y, and Z. So we have the pattern here. All the numbers are whole numbers. What number does X represent? What number does Z represent? So for this type of question, this might become a little bit tricky, but Pre-Uni has done some of these questions like this, where there are scenarios where you choose a number first and then it comes into a pattern to help finding an unknown. So simultaneous equations come really handy in these types. So we can firstly start off by noting that after each of the numbers are chosen, the sum of the 3 numbers is equal to the next number. So we can write what this means is that 2 plus X plus 0 is equal to Y from here, which means 2 plus X is equal to Y, which is our first equation. Then we have X plus 0 plus Y is equal to 6. So X plus Y is equal to 6, which is our second equation. And then Y plus 6 plus 0 is equal to Z. So Y plus 6 is equal to Z, which is our third equation. So now we can choose many ways or many methods to solve this. But one way to solve this is from equation 1, we have 2 plus X is equal to Y. We can have X is equal to Y minus 2. And then sub this into equation 2. So we have X plus Y is equal to 6. Y minus 2 plus Y is equal to 6. 2y minus 2 is equal to 6. 2y is equal to 8 and y is equal to 4. And thus, in equation 3, y plus 6 is equal to z. 4 plus 6 is equal to z. So z is equal to 10. And that is our answer. So z represents 10. So option C is correct. So one thing to note with simultaneous equations is that there are so many ways you can do them and solve which pronumerals to isolate and to sub in. So this is just one method of many. With question 34, we have category, finding procedures, description, number concepts, skills, making deductions using number knowledge and given information. So for 34, in a game, I collect stars and hearts. I get points when I collect a star. The number of points for a star is always the same. I get a different number of points when I collect a heart. The number of points for a heart is always the same. If I collect 3 stars and 5 hearts, I get 27 points. If I collect 5 stars and 7 hearts, I get 41 points. How many points do I get if I collect 1 star and 1 heart? So for this question, this also involves simultaneous equations and is also quite common with the diagrams and the pictures that is also seen in STTC GA and Maths. So one approach we can do is we can simplify our simultaneous equations. So we can have 5 stars, so S, plus 7 hearts, so H, is equal to 41. So from there. And then we can have 3 stars plus 5 hearts is equal to 27. Now with these two equations, we minus them. So we have 2 stars plus 2 hearts is equal to 14. We have common factors across. So we have star and a heart is equal to 7. And that is actually what we are trying to find, 1 star and 1 heart. And that equals to 7. So A is the answer. So students can identify these methods and can confidently do simultaneous equations. It makes it a whole lot easier for them to solve questions like this. And then for the last sample question, question 35. So our category is finding procedures. The description is number concepts, and the skills is making deductions using number knowledge and given information. So for 35, how many whole numbers between 1 and 100 are multiples of 3, but not multiples of 8? You should include 3 in itself. So for this type of question, this is also quite familiar in GA and maths. And one approach is just to write out all the multiples that satisfy the conditions that they are not multiples of 8. So if we write it out, we have 3, 6, 9, 12, 15, 18, 21. Now 24 is a multiple of 8, so we don't include it. 27, 30, 33, 36, 39, 42, 45, 48 is also a multiple of 8, so we cross that out. 51, 54, 57, 60, 63, 66, 69, 75, so we crossed out 72, 78, 81, 84, 87, 90, 93, 96 is a multiple of 8, so we don't include it, and 99. So once we've listed all of these out, when we count each one, we know that there are 29 multiples of 3 that are not multiples of 8 also. So D is the answer. So now that we have finished going through the sample questions, there are just some tips for each of the category questions that students should try to take advantage of. So for finding procedures, it is important to understand what the question is exactly asking for. So use this to determine how you will solve the equation and what method you could use to get there. So don't panic if the answer is not immediately obvious. These questions involve using your reasoning skills and understanding of various maths and concepts. For identifying similarity, when attempting these, compare the types or sets of data and look at how they are related to each other and what the question is asking for. And lastly, for relevant selection, so not all of the information in this question will necessarily be useful in finding the answer. So it is the student's job to determine what is relevant, and so you could sift through information to get to the answer. So that brings us to the end of this informational video. Hopefully that with the changes coming in for the selective high school placement test, that you have been able to get a better understanding of the test structure and the questions that are involved.